What's up, everybody? Welcome in. We're going to learn about gas giants tonight. Gaseous planets. All right, gas giants are my favorite class of planet. Um, I just took a poll, or I answered a poll. It was like if you could, explore space, what type of planet would you like to visit? And it was Earth, like by far, like 90%. I was kind of shocked at how little support gas giants got, but I guess it makes sense. Like, they don't have a surface, so there's nothing to land on, and I mean, there could be life on gas giants, but it wouldn't be like intelligent or anything, most likely. But you know. I can see why people would want to do Earth. Like I just like the gas giants. It's like when I went to or when I played the game Space Engine, which is a game where you can basically explore the entire observable universe, and it's like a procedurally generated artificial intelligence. I think that's what it's called. Like it generates these planets, and like basically in real time. It's a really cool game. It's not even a game. It's really just a simulator slash like virtual like planetarium really. Um, but yeah, I have a vision here. One day I'm gonna reacquire a gaming laptop, like a legit game laptop. I had an Acer Nitro 5 one time, which is a great laptop, and it could play that game and run that game. And I'm gonna do this type of video, interesting facts, mind blowing facts, and then we're gonna go visit the planet or the type of planet we talk about within the game, so we can get a visual on it. And anyways, there's always I'm always trying to grow, always trying to expand the channel because no, I don't believe in staying stagnant. The channel's grown a lot since I first started. It used to just be bullshit video games, with no title, no thumbnail, and now I'm doing space facts. So do a lot more than that. Airplane, space, gardening mainly these days. Yeah, just go take a look. I mean, it's all there. Anyways, I commanded Google AI tell me interesting facts about gas giants. Okay. Size and composition. Gas giants are large planets that are primarily composed of gases, mostly hydrogen and helium. In our solar system, they are much larger than the terrestrial planets like Earth. Examples include Jupiter and Saturn, which are considered gas giants due to their composition. If you're wondering why no Neptune and Uranus, those are ice giants. No solid surface. Unlike rocky planets, gas giants don't have a solid surface that you could land on. Their atmospheres gradually become denser as you go deeper towards the core. You just get crushed immediately and just burn away. It's not a very hospitable environment. Very violent. Like those Jupiter looks the way it does. Those are storms. Winds circulating on that around that planet. Interiors. Beneath their thick atmospheres, gas giants have layers of highly compressed I almost combined the words hydrogen and helium. Jupiter and Saturn likely have layers of liquid metallic hydrogen, which is something I'd love to see. Liquid metallic hydrogen. That can only exist in just very extreme conditions, obviously, which conducts electricity. Uranus and Neptune, while still considered gas giants in broader terms, are sometimes more accurately referred to as ice giants because they contain a larger percentage of volatile ices like water, methane, and ammonia, in addition to hydrogen and helium. These elements would have been in solid ice form when the planets formed. Okay. Then why do we call them gas giants at all? Like they're just legit ice giants. I wish we could would I wish words would have meaning again. You shouldn't call them gas giants when they're mostly ice. Like what do you mean sometimes more accurately referred to as? Is it accurate or not? I just believe in factual information. I don't like playing games with words and playing semantic games. I don't believe in that. Words are words, and they have meaning. Rings and moons. All four gas giants in our solar system, all two gas giants in our solar system, have ring systems. Although Saturn's are more prominent and well known, did you know Jupiter have rings? It is very faint. They also have numerous moons. Saturn currently holds the record for the most moons with 82, followed by Jupiter 79. They're not going to expand on why that is. I mean, it's just because they're larger and the mass is they have more gravity, which is will suck more objects towards it. In this case, these rocks, these rocky worlds, these moons. And man, we're gonna learn about Jupiter's moons. There's some very exciting, very potentially just very I'm just saying very interesting. I'm not very articulate at midnight, but luckily my brain works at all. There's very interesting moons. Some may have subsurface oceans. Okay, with liquid water. Rapid rotation. Gas giants rotate relatively quickly compared to Earth. Jupiter, for example, has a day that lasts less than 10 hours. Well, wind bands and storms. Gas giants exhibit striking atmospheric phenomena such as visible wind bands that stretch across their surfaces. They also experience massive storms. Jupiter's red spot is a famous example, an ancient storm larger than Earth and has been observed for centuries. Magnetic fields. I love the band, the magnetic fields. Jupiter and Saturn have strong magnetic fields. Jupiter's magnetic field creates auroras at its poles, similar to Earth's northern lights. Yeah, that's what creates the auroras, if you've seen them, like little, dancing green lights. Failed stars. Jupiter is sometimes referred to as a failed star because its composition is similar to that of a star. However, it isn't massive enough to initiate nuclear fusion in its core and generate its own light and heat like a star. That's what ignites a star and make it shine. The nuclear fusion happening at its core. It would need to be about 80 times larger or more massive to become a star. Exoplanet diversity. Let me leave a thumbs up. I like this Google AI for the most part. There's some stuff I've seen that kind of annoys me. Like sentences back to back worded in different ways or just plain inaccurate information. But for the most part, I know it's in its infancy, very early stages. It's good, but I try to leave a thumbs up on the useful ones. Exoplanet diversity. Beyond our solar system, astronomers have discovered many gas giants orbiting their orbiting other stars. These can range in size and distance from their stars, including categories like hot Jupiters, gas giants orbiting very close to their stars, and super Jupiters. See that 5 times fast. Gas giants more massive than Jupiter. In short, gas giants are fascinating and diverse worlds that play a significant role in planetary systems, both within and beyond our own. Their unique characteristics include their lack of solid surfaces, layered interiors, and atmospheric dynamics continue to intrigue scientists. I'm intrigued by the moons. You know what? I said we're going to learn about the moons in a. Let's just learn about right now. Okay, we'll just combine. Tell me about the let me see. I can narrow it down. It's like almost eight or over 80 moons. What is it? Europa? I believe it's Europa. Tell me about Europa's subsurface ocean. Europa, one of Jupiter's moons, is a fascinating world that's believed to harbor a vast hidden ocean beneath its icy crust. Magnetic field. The Galileo spacecraft detected disturbances in Jupiter's magnetic field around Europa, suggesting the presence of a conductive layer underneath the surface. Scientists propose this layer is a salty liquid water ocean interacting with Jupiter's strong magnetic field. How exciting would it be if there's life in there? And you may be wondering, how could there be life in a subsurface ocean where there's no sunlight reaching it? Because of the vents that near the seabed, the ocean surf, or I guess what do you call it? I guess it would just be seabed, the ocean bed. There's like vents near that would conduct enough heat to allow Earth or allow life to form. Surface. That's how I think it's how life first formed in Earth's oceans. It wasn't so much the sun reaching it; it was those. I think they're called hydrothermal vents. Let me look it up actually right now. I don't want to say anything inaccurate. There you go. Hydrothermal vents are openings in the seafloor where geothermally heated water is released, often near volcanically active areas like mid-ocean ridges. These vents create unique, self-contained ecosystems fueled by chemosynthesis, where microorganisms convert chemicals into energy, supporting diverse life forms adapted to extreme conditions. There you go. That's where life comes from. You don't need sun for life. It's a nice added bonus, but yeah. Anyways, let's get back to what we were looking at. Okay. Images from various spacecraft show surface features like cracks, ridges, and chaos terrain. that are consistent with a dynamic ice shell floating on a liquid ocean. Tidal forces from Jupiter cause flexing of the moon's interior, likely generating enough heat to keep the subsurface water liquid. Plumes. Observations from the Hubble Space Telescope have indicated the possible presence of water vapor plumes erupting from Europa's surface. If confirmed, these plumes could provide a way to sample the ocean's composition without needing to drill through the ice. Yeah, drilling is really a fantasy. It's just insanely deep beneath the surface. We don't even have drills that could drill that far to test the water. If I read correctly. Um, Europa's surface ocean is estimated to be 40 to 100 miles deep. What? 40 to 100 miles deep? That's fucked up and terrifying to think about. Anyways, it may contain more water than all of Earth's oceans combined. There you go. Like, does that not blow your mind? This ocean on a moon has more water than all of Earth's oceans combined. 100 miles deep. Yeah, I think there's gonna be life there, like most likely. Composition. The ocean's composition is believed to be similar to that of the Earth's oceans, with a possible salinity, saltiness, that could support life. Recent observations using the Hubble Space Telescope suggest the presence of sodium chloride table salt on Europa's surface in how'd they get there? In geologically active regions, which may be upswelling from the subsurface ocean. Like, hey, why would people be surprised by this? It's our solar system. Everything was closer once. Like, if there's icy oceans here, why wouldn't there be somewhere else in our solar system? Earth isn't unique. Interaction with rocky interior. We'll stop. Well, actually, no, we'll stop at potential for life. We'll leave the exploration for another time because there's a mission that we'll expand on at a later date. Because I want this video to be just ridiculously long. Because I actually want some people to that have the brain power to actually watch it and get something from it. Anyways, composition. The ocean's composition is believed to be similar to that of Earth's oceans with a okay, I read that. Interaction we read that to no, we didn't. The ocean likely interacts with Europa's rocky interior, potentially providing essential chemical nutrients and energy for life, similar to what occurs around hydrothermal vents. There you go. Is what I was talking about. I know my shit, people. I never come here and talk bullshit. I've done they don't sit for over a decade of research on space, just on my own time for pleasure. Hydrothermal vents. That's what that like on the Earth's ocean floor. I guess where life comes from. Anyways, potential for life. Ingredients for life. Europa's subsurface ocean contains liquid water. The interaction between the ocean and rocky seafloor could provide the necessary chemical building blocks and energy sources for microbial life. That's where it all begins. Like all life on Earth came from the ocean at some point. Redox potential. A redox potential could be created by the interaction of oxidants formed by radiation on the surface and reduced molecules from the seafloor, which is crucial for energy extraction by life as we know it. There you go. That's why gas giants excite me. This the way they tug and squeeze these moons that cause a lot of activity beneath that surface, and these hydrothermal vents. Those two combined, you may get life, but without the sun. But yeah, there you go. Um, yeah, 14 minutes is a good place to stop. We're not gonna look at any gas giants actually. Let's keep this sterile, just information. Next time we look at the gas giants, what they may look like, artist renderings, obviously. I don't think we have any direct observation, of any gas giant besides, like, Jupiter and Saturn, obviously. But we'll look at those artist renderings and we'll look at the mission to Europa and have that explain what that's looking for and how long it's going to take. And yeah, that's it, guys. That's gas giants in Europa. See ya.